Good morning, everyone. Myself, Pradeep Kumar Verma from Electronics and Communication Engineering Department, Ashoka Institute of Technology and Management. Today, we are going to discuss an important topic from the subject Information Theory in Coding, and that is source coding. Will be we will be discussing Huffman coding today. Now, what is source coding? Source coding is the efficient representation of data generated by a source. As we can see in the diagram, there is a discrete memoryless source which is generating symbols, and there is a source encoder. This discrete memoryless source will give the input to the source encoder, and here the symbols will be encoded in bits, and the result of the source encoder will be binary bits. Suppose there are k binary symbols, or you can say, sorry, discrete wireless source is there. It is producing k symbols, and we need to encode these symbols in binary sequences, and the symbols that are generated at random that have probability p, and a subscript k is basically added to p to denote that particular symbol, and the symbols are denoted by sk, where k is equal to 0 to k minus 1. Then the average code word length of the source encoder will be given as L is equal to summation k is equal to 0 to k minus 1 pk lk, where pk is the probability of the kth symbol and lk is the length of the kth symbol in bits. Now, if we want to just calculate the efficiency of the source getting technique we are using, we can calculate it by the formula eta is equal to L minimum upon the average code word length that we have calculated or studied in the previous slide. And L minimum is nothing but the entropy of the random variable or discrete memoryless source. So if we are encoding symbols from the source generated, we need to have such a coding technique that can remove the redundancies in the information. So here we just will be studying some techniques that use data compaction, and they will remove the redundancies, and then we will transmit it further for modulation, and then you can say channel encoding, and then it could be transmitted over a channel. Some of the source coding schemes that we have to study the Huffman coding, Shannon-Fano coding, and Shannon-Fano alias coding. But in this lecture, we will be focusing on Huffman coding. In the previous lectures, we have studied about various types of codes. Uh, in that, we studied about prefix codes, as can be seen in the table. There is a source producing S0, S1, S2, S3, four symbols, and the probability of occurrence of each symbols is given in column 2. that is 0.5 for S0, 0.25 for S1, 0.1254 for S2 and 0.1254 for S3. There are three codes regarding these symbols: code 1, code 2, code 3. And next we have to just analyze these codes and decide if these codes are prefix codes or not. So one important property of the prefix code is that it is uniquely decodable. So first we have to check if this code given is uniquely decodable or not. As can be seen that code 1 is not uniquely decodable, therefore it is not prefix code. Then we have code 2. It can be said that it is also uniquely decodable, as all the source symbols are coded in such way that any combination of the codes or symbols does not represent any other code of a symbol or group of symbols. And code 2 is yes prefix code, and code 3 is not, as the code of S0 is acting as a prefix for code of S1 in code 3, and the code of S1, that is 01, is acting as prefix in code of S2. So we have an example for the students to just look at this table and just verify, analyze which of these codes are prefix code and which of these are not. So by looking at these codes, we can say that code 1 and code 4 are prefix codes and code 2 and code 3 are not. So basically then we come to Huffman coding. Huffman coding is a type of prefix code, and the algorithm that we use for coding the source symbols by Huffman coding is step 1. First of all, we arrange all the symbols in decreasing order of their probability of occurrence first. Then in step 2, we combine the least two probable symbols, their probabilities added together and formed a new symbol, and then all these probabilities are uh, then arranged again in the decreasing order, and this step is followed until we are left with only two probabilities at last. Since we are using binary coding, therefore we have to do this step 2 till the two probabilities are left. So there is an example. Suppose we have a discrete memoryless source producing five symbols S0, S1, S2, S3, S4, and their probabilities are as zero point 0.4, zero point 0.2, zero point 0.2, zero point 0.1, zero point 0.1 respectively. We will arrange these in the decreasing order of probabilities. So S0 has a probability zero point 0.4, therefore it will be topmost, then zero point 0.2 for S1, then zero point 0.2 for S2, then zero point 0.1 for S3, and zero point 0.1 for S4. Then next we will add these least two probable symbols probabilities, that is zero point 0.1 plus zero point 0.1, we will get zero point 0.2, and this zero point 0.2 is then arranged in stage 2 with all the remaining other probabilities in decreasing order. As we can see, the arrow is pointing towards this. Then we will again add the least two probable symbols, that is point 2, point 2, we will get point 4. This can be arranged in stage 3 as shown. The sum, that is point 4, is placed at top. Then the symbol that is has probability point 4 is arranged next. Then the addition of S3 and S4 probability, that is point 2, is arranged next. Then we will perform another addition, that is we will add point 4 and point 2, since these are the least two probable symbols, and we will get point 6. In stage 4 we will then again arrange these probabilities in descending order, that is point 6 and point 4, and in stage 4 we are left with only two probabilities. Then we will stop at this moment and then assign the codes. So we will assign 0 to the upper symbol and 1 to the lower symbol, as can be seen by the red circle here. We have assigned 0, and by the blue circle we have assigned 1. Then by going backwards we can see that point 6 is a combination of point 4 plus point 2. Then the code for point 6 is 0, so we will just write down 0 for both the point 4 and point 2. Then we will again assign uh, the zeros and 1. So we will assign 0 to the upper symbol, then 1 to the lower. Similarly, we can trace back this to the final stage 1, and we will get the code words as follows, as shown in figure B. For S0 it comes out to be 0 0, for S1 it is 1 0, for S2 it is 1 1, and S3 it is 0 1 0, and for S4 is 0 1 1. So as we can see in this coding technique, that the most probable symbol, that is the symbol with highest probability of occurrence, will be assigned the least number of bits in the code word, and the code with least probability will be assigned a code word with the maximum number of bits. And there is one more property, that is the least two probable symbols will have the number of bits, same number of bits, and they will only differ at the last bit. So these are the two properties that we get in Huffman coding. Then we need to calculate the average code word length. We can calculate it by the formula as was stated earlier. L bar is equal to summation k is equal to 0 to k minus 1 pk lk, where lk is the length of each code word. So we have calculated this. When we put k is equal to 0, that is it will be p0 into l0. P0 is nothing but 0.4 and l0 is 2, that is 2 bits for s0. Then if we will put k is equal to 1, then it will come as p1 l1. So p1 is zero point 0.2 and l1 is again 2 bits. So zero point 0.2 into 2 plus, when we put k is equal to 2, so it comes out to be p2 l2, since probability of second symbol is zero point 0.2 s2, and the code word is 2 bit length. So again zero point 0.2 into 2, then we will carry on like this only till k is equal to 4, and if we sum these we will get 2.2 bits per symbol. So I have another exercise, that is we have to compute the Huffman code And the average code word length symbols are given as S0, S1, S3, sorry S2. There are only three symbols, and the probabilities are zero point 0.7, 0.15, 0.15 respectively. So I have done this. We will again use the same algorithm and find out the code as is shown in the PPT. Then the average code word length comes out to be 1.3. So for now, this was the explanation for Huffman coding. Thank you.